Today we're going to look at example 2. We're looking at finding the slope of the tangent line using a couple different formulas, both using the limit process. So these are the formulas we'll be using to get our slopes. Once we get the slope of the tangent line, we're going to write the equation of the tangent line, and then we'll check our answer using Desmos. So first example we have here, f of x is 2x minus x squared, and we're looking at the particular x value here, a equals 3. And so if I look at using the first formula here, the slope of the tangent line would be the limit as x approaches 3 of f of x minus f of 3 divided by x minus 3. And in this particular case, the f of x is 2x minus x squared. And so the f of 3, we would substitute in 3 here, 2 times 3 minus 3 squared. And if I go through the arithmetic here, I've got a 6 minus 9, so that's a negative 3. So this would be the limit as x goes to 3 of 2x minus x squared, that's the f of x, minus the negative 3 divided by x minus 3. Be the limit as x goes to 3 of, I'd have a minus x squared plus 2x plus 3 divided by x minus 3. And as we mentioned in class, every single one of these, when you do a direct substitution, x equals 3, you're going to get, you should get a 0 in both the numerator and denominator, because we're looking at this instantaneous slope. So we think back to our techniques of evaluating limits. And one of the first techniques we have to resolve indeterminate forms is to factor numerator and denominator. So thanks to the factor theorem, we know that if x equals 3 produces a 0 in the numerator, I am guaranteed by the factor theorem there's a factor of x minus 3 there. So what would be the missing factor here? I would need a minus x to get the minus x squared. And I would need to get a minus 1 to get the plus 3. Oops. And we can do a quick check. X times negative x. There's your negative x squared. We'd have a negative x plus 3x. Give us the plus 2x. Minus 3 times minus 1 gives us the plus 3. Sure enough, we see here that we can completely cancel the x minus 3 factor, and we get our answer is negative 4. So using this limit process, we get the slope of the tangent line is negative 4. And so if we wanted to check graphically, to get the equation of the tangent line, y equals the slope of the tangent line times x minus a plus f of a. In this case, slope of the tangent line is negative 4. We're looking at x minus 3 plus f of 3. And we did f of 3. Here we computed f of 3 is negative 1. So we have minus 4 x minus 3 minus 3. So that would give us a minus 4x plus a 12 minus a 3. That'd be plus 9. So if we want to check that that really and truly is the tangent line, I'm going to graph the function. I'm going to graph the line, and I'm going to look at how they look near the point in question here when x equals 3 and at f of 3. So our function f of x is 2x minus x squared. We're looking at the point 3 comma f of 3, which is right there. Boom, 3 negative 3. And we're looking at the line y equals negative 4x plus 9. There we go. And now as I zoom in to the graph near the point 3, negative 3, we can see that the graph of the function and the graph of the line become indistinguishable. So that's the local linearity. If we wanted to get the slope of the tangent line using this other method, once again, we'll get it set up, and then I'll have you work through the details. This would be the limit as h goes to 0 of f of a plus h, so 3 plus h, minus f of a, f of 3 divided by h. And so here, the f of 3 plus h means everywhere we see an x, we're going to replace it with the quantity 3 plus h. So I'd have 2 times the quantity 3 plus h minus the quantity 3 plus h squared. So that would be 2 times 3 is 6 plus 2h minus, and remember, when in doubt, FOIL it out. 3 plus h times 3 plus h, you got your 3 times your 3. You got 3h, 3h, so 6h altogether, plus h squared. So if you distribute the negative, we're going to end up with negative 1h squared, 2h minus 6h, negative 4h, 6 minus 9, negative 3. And f of 3, well, that's the same value as it was before. That's a negative 3. So this would be the limit as h goes to 0 of f of 3 plus h minus h squared minus 4h minus 3 minus f of 3, so minus a negative 3, all divided by h. So if you look at what's going on here in the numerator, I'd have a minus h squared minus 4h minus 3 plus 3. So those would cancel out. And let's go ahead and finish this one off here. So when the dust settles in the numerator, I'm left with a minus h squared minus 4h divided by h. So, as promised, I can factor out an h. Look what happens. I get negative 4, same answer I had before. Okay? And so, once again, that's what should happen on all of these examples, is regardless of which limit process you use, you should get the same slope. Next example, we're looking at f of x equals 1 over x. The particular x value here, a equals 1/2. So the slope of the tangent line using the first formulation would be the limit as x approaches 1/2 of f of x minus f of 1/2 over x minus a half. The f of x here is 1 over x, so f of 1/2 would be 1 over 1/2. And per fraction gymnastics, that's going to flip that 1/2 around and get you back to a 2. So this would be the limit as x approaches a half of 1 over x minus 2 divided by x minus a half. Once again, if you plug in the x equals 1/2, direct substitution is going to result in a 0 over 0, as all of these difference quotients will do. So we got to think back to our strategies. Once again, thinking ahead here, we really want that x minus 1/2 factor to cancel from the denominator. So what do we have to do? We need to simplify the complex fraction up top here. So we're going to multiply numerator and denominator by x, because that's the small denominator up here. Limit as x goes to 1/2 of. Now the denominator we're not going to factor out, multiply out, because we're hoping to cancel the x minus 1/2. Let's see what happens in the numerator. X times 1 over x leaves 1 minus 2x. And if I want to get an x minus 1/2 out of that, I'm going to have to factor out the coefficient of x, which is a negative 2. Okay, and we've seen this before. Factoring out is the same as dividing. If I factor out negative 2 from negative 2x, I'm dividing negative 2x by negative 2. That's going to leave me with an x. Factoring out negative 2 from a positive 1 means I'm dividing 1 by negative 2, leaves me with a minus 1/2. Boom, there we go. And now I can substitute. Plugging in 1/2 for x, I get negative 2 over 1/2. And once again, I get negative 4. So the slope of the tangent line here is negative 4. The equation of the tangent line, y equals the slope of the tangent line times x minus a plus f of a. The slope here is negative 4. The x value is 1/2. We know the function value is 2. So let's simplify. Negative 4 times x. Negative 4 times negative 1/2 is a positive 2. Plus positive 2 is positive 4. So if I graph my function, and I graph this line, and I zoom in near the point 1/2, 2, the graph of the function and the graph of the line should be indistinguishable. So let's fire up Desmos. So now our function is 1 over x. We're looking at the point 1/2 comma f of 1/2. We're looking at y equals negative 4x plus 4. So let's zoom out here and see what we can see. Here we go. Looking good. There's the point there on the graph. And we can see that as we get near the point 1/2 comma 2, the graph of the function and the graph of the line become indistinguishable. We get the slope of the tangent line using the alternate formulation here. So another way to get the slope of the tangent line is we're going to take the limit as h goes to 0 of f of a plus h. So in this case 1/2 plus h minus f of a divided by h. So once again, our f of x is 1 over x. So that means our f of 1/2 plus h would be a 1 over 1/2 plus h. The f of 1/2 is still 1 over 1/2, which is 2. So let's feed all this into the difference quotient and see what we get. We look at the limit as h goes to 0 of 1 over 1/2 plus h minus 2, all divided by h. Once again, if you substitute in h equals 0 directly, you're going to get a 0 over 0. And once again, we have a complex fraction. So what we're going to do to get started is multiply numerator and denominator by the 1/2 plus h. Multiply here the first term, we're left with a 1. Multiply here the second term, we got to multiply this by 2. And once again, the denominator, we're just going to leave it factored because eventually we want to try to cancel that h out. So I got the limit as h goes to 0 of 1 minus 2 times a half is a 1. 2 times the h is a 2h. And so we see in the numerator, these 1's cancel out. We're left with a negative 2h. And in the denominator, we're left with h 1/2 plus h. And now we see that this factor of h causing a 0 in the denominator will cancel out. So now we're all set to substitute in h equals 0. We get a minus 2 over 1/2 plus 0. So minus 2 divided by 1/2, sure enough, that's negative 4. So once again, it doesn't matter what limit process you use, you should get to the same slope both times. So that'll do it for example 2.